And again, when you kind of looked at what were the worst case expected conditions out at the pad versus, potentially being stuck on the crawlerway, those were some of the decisions involved in the risk trade there in terms of writing it out. We did look very carefully at, what were the worst expected conditions and ensured we were well within our design envelopes for all of those cases.
Yeah, Jeremy, I think you said it really well. Ken, obviously the best place to be in a storm is in the VAB. The second best place is at the pad. The worst place to be is stuck out there on the crawlerway. And as Jeremy outlined, we had a risk versus risk trade, and there was some uncertainty in the forecast. And we know that the loads that the vehicle could handle by design at the pad, just sitting there at the pad hard down, are higher from a wind standpoint than if we're rolling, because you need to account, when you're rolling, you need to account for the loads. The analogy that we've discussed is just kind of like, being in a pickup truck going down a bumpy road. When you're on the crawlerway, you do impart loads on the rocket. Granted, you aren't moving very fast, but there are loads there. And you need to subtract that out from any wind conditions that you're going to see, and the winds that were forecast at the time, the time that we could roll back in that time frame, were in the range that we thought we had more margin from a vehicle structure standpoint, staying at the pad and riding it out than rolling back. And if we rolled back, we would be accepting the risk that we could have a problem with the crawler transporter during that time frame and be stuck out there on the crawlerway and not make it back to the vehicle assembly building. And it sounds like a relatively simple and relatively straightforward thing to do, but it is not. This crawler transporter, if you've ever walked up to it and seen it in person, you feel very, very small. And that is without the rocket, 32 stories sitting on top of it, or with the mobile launcher. The mobile launcher itself weighs 11 million pounds. The rocket's dry weight is a little over 2 million pounds. So when you roll the entire stack, the mobile launcher with the Orion spacecraft and the Space Launch System rocket on it, on the crawler transporter, you've got tens of millions of pounds going across the ground. And again, it was a risk-on-risk trade. It was not an easy decision. It was a fairly long discussion that we talked about, and we did not take that decision lightly, but those were some of the factors that went into it.
Thank you. That is all of the time that we have for questions today. Thank you all for joining us. You can listen to a replay of this teleconference online shortly by visiting the Media Resources tab at nasa.gov/Artemis-1. And join us tomorrow for our launch coverage, which begins with NASA television coverage of tanking and commentary from inside the Launch Control Center, beginning at 3:30 p.m. Eastern. And you can follow along at our blog for updates about the mission as well at blogs.nasa.gov/Artemis. With that, thank you for joining us.
Thank you for your participation, participants. You may disconnect at this time. thank you for standing by. Today's conference is being recorded. If you have any objections, you may disconnect at this time. I would now like to turn the conference over to Katherine Hamilton. Thank you. You may begin.
Thank you. I'm Katherine Hamilton with NASA's Office of Communications. Teams gathered today to review the overnight operations and the additional analysis requested during yesterday's mission management team meeting in preparation for launch. Teams are proceeding toward a launch on Wednesday, November 16th, during a 2-hour launch window that opens at 1:04 a.m. Eastern Time. Here to give us an update on the countdown and launch operations, as well as today's mission management team meeting, are Jeremy Parsons, Deputy Manager for the Exploration Ground Systems Program at NASA's Kennedy Space Center, and Mike Serafin, Artemis 1 Mission Manager from NASA headquarters. Jeremy and Mike will share a few opening remarks, and then we'll take questions. Reporters on the line can enter *1 on your phone to be entered into the question queue at any time. Jeremy, we'll start with you.
Good evening. Thank you, Catherine, and thank you for the folks that have interest on the call here. So per plan, the team was on console for call to stations at 1:24 a.m. this morning. Countdown to, so far is proceeding very well, and we are on schedule. So what have we been doing since the discussion in the conference last night? So last evening, we powered up the vehicle. We ran a series of what we call program-specific engineering tests, or PSETs. It's basically integrated vehicle testing, and all was nominal. So it was a very thorough checkout of the vehicle. Everything's looking really good. On the mobile launcher, we're getting panels and valves all configured for cryo loading. We filled the sound suppression and ignition overpressure tank, the big water tank out at the pad. And then we've brought up power on Orion, the upper stage ICPS, and core stage. So they've all been powered up at this time. And we're going to remain with those up for the remainder of launch countdown. We also have been working in troubleshooting of the J8 connector that was discussed last night. I'll give you a little bit more details on that in just a minute, but before I do that, I'm going to go through what you can expect tonight and into tomorrow in terms of launch countdown. So tonight, we're going to begin charging all the flight batteries on the vehicle. We're going to get into pressurizing the core stage composite overwrap pressure vessels. We'll do final walkdowns tonight and through tomorrow, and we'll do a series of comm checkouts with Orion. Going into tomorrow, we pick up with our blast danger area clear at 12:04 Eastern. We get into air to GN2 switchover at 13:14. We clear out the entire launch danger area for all personnel at 2:04, and then we get into the new built-in hold at 14:24. So that's at the T-minus 6 hour 40-minute mark. So when I say it's new, it's the same built-in hold. Previously it was 2 hours and 30 minutes. We have added an hour in for cryo-loading concept of operations changes. Just a kind of a quick level there. So we added an hour basically to do a slower, more gentle LH2 loading procedure. So it adds about 17 to 20 minutes for LH2 chill down and 32 minutes for fast fill. We're also now doing liquid oxygen and liquid hydrogen loading in parallel. So with all that picks up, again, that built-in hold picks up at 14:24, and then we expect the launch director to give a go for cryo loading at 15:24. T0, as Catherine mentioned, is at 1:04 a.m., and we got a 2-hour window fully available to us. So real quick, and then I'll pass it over to Mr. Serafin. The J8 connector. So team got in late last night. We had already changed out the cable, done a series of ring out testing on that. We then changed out the ground receptacle side of this, and so that's on the back of the LH2 tail service mast umbilical plate. We did that change out and then performed a series of retests. Team did a really good job wringing out all of the data, determining the wrist posture, looking at all measurements flowing through there, where redundancy occurs, what launch commit criteria are associated with them. At a top level, what we were basically seeing was measurement transients during power-up, so they would go out of kind of expected ranges for a little bit when you first power up, and then they would come back into nominal ranges. We are already in a powered-up configuration on all of the core stage ICPS and Orion, and we're going to remain in that configuration through the rest of Launch Countdown. So all of these are kind of at a normal, stable configuration. That being said, we went through each of these launch commit criteria that are associated with these measurements, determined criticality, redundancy, and what we call pre-planned contingency procedures, which is basically allows us to say we take failures on any of these measurements, say we know we have redundancy in these other measurements, and we are still okay to launch. The unanimous recommendation for the team was we were in a good position to go ahead and proceed into Launch Countdown with these measurements, and that was, again, based off the criticality and redundancy posture that we have. And really, we have a very robust system here with a number of measurements in other areas. So with that, Catherine, I'll turn it back to you. I believe that's kind of a summary of where we're at.
Thank you, and we'll go to Mike Saracen. Thank you. We'll go to Mike Saracen next.
Okay, good evening, and thank you again for continuing to follow the Artemis program and the Artemis 1 mission. This afternoon, we had a launch minus 1 day mission management team meeting. The mission management team met for 1.5 hours this afternoon, and the primary purpose was to focus on 2 special topics. The first was the status of the liquid hydrogen umbilical electrical connector located at the J8 port that Jeremy described, and we went through a status of the connector removal and replacement and the work that was completed, any findings that we had as a result of it, and then the post removal and replacement systems status checks. Right now, as Jeremy described, we don't have any changes to our posture as we head into the launch attempt. The launch commit criteria were reviewed, and we agreed that the as-written launch commit criteria were the appropriate posture to have headed into the next attempt. That's largely based on the fact that we have systems redundancy as it pertains to the signals that we need to verify as part of those launch commit. The other item that we talked was the one open action that we took out of the launch minus 2 day review held yesterday, and that pertained to the Orion room temperature vulcanization material, or RTV material, delamination that we saw during Hurricane Nicole. On the east side of the vehicle, or roughly in the Orion coordinates, the 270-degree location on the aerodynamic shell called the ogive, where that meets up with the crew module adapter. We had a strip of that RTV delaminate during the storm, during the windy portion of the storm. And the purpose of that RTV is essentially to fill in the gap that exists between the launch abort system ogive and the crew module adapter. There's a small area that exists where the two made up, where we have an aerodynamic barrier, and it could actually cause a little bit of air circulation in there as we ascend through the Earth's atmosphere and cause aerodynamic heating. So to eliminate that little gap, they put this RTV material in there, and it just creates a very flush surface, a very streamlined aerodynamic surface. Yesterday, when we reviewed the status of that particular delamination that we observed and the likelihood of a reoccurrence during flight, we needed a little bit more time to review our flight rationale, and the team came back and we accepted that flight rationale today based on a proven methodology called the 7 elements of a good flight rationale. And we looked across the entire vehicle stack from the Orion spacecraft all the way down to the base of the stack, and we agreed that the risk was bounded by current hazards and hazard reports that we have out there well before that were established well before the agency flight readiness review, and when we accepted our risk baseline at the agency flight readiness review. So we went through that today, and we closed that action item, and we accepted that flight rationale, and it just was one of those circumstances yesterday where the team needed a little bit more time to assess our overall risk posture and to understand this new issue that had occurred earlier or mid last week as a result of Hurricane Nicole. So we went through that. I asked if there were any dissenting opinions. There were none, and we accepted that flight rationale. So that was the purpose of today's Launch Minus One Day Mission Management Team meeting. We are proceeding to the next decision gate to set up for the November 16th launch attempt, as Catherine indicated at the outset. So there's no change in our plan to attempt to launch on the 16th. The next decision gate occurs tomorrow afternoon at 2:30 in the afternoon Eastern, and that's our tanking decision gate, and we'll get together again as a mission management team. So with that, that was the outcome of our meeting today, and we look forward to the tanking tomorrow afternoon, and I'll pass it back to you, Catherine.
Thank you. We'll now begin our question and answer session and take questions from reporters on the line. Those on the phone can press *1 to be entered into the queue at any time, and press *2 if you'd like to be removed from the queue. Your lines are on mute now, and the operator will open and close your mic when we come to your question. Please identify to whom your question is addressed, and we ask you to please keep it to one question so we can get to as many reporters on the line as possible, and if we have time, we will do a second round of questions. We'll start with Kristen Fisher of CNN.
Thank you both so much for taking our questions tonight. Two questions for you, and I'll try to keep them brief. I just want to make sure that I have it right in sort of, layman speak. Would it be fair to say that these two issues that have given you guys some trouble over the last 24 hours or so, the damage caused by the hurricane, that the the RTV material and this umbilical, that those two issues have been fixed, or that you all are just now comfortable with proceeding with them as is? If you can just kind of give some clarification as to how we should refer to that, I would appreciate it. And then my second question is, if each of you had to pick one moment in the countdown between now and liftoff that gives you the most heartburn to think about, what moment would that be? Thank you.
Yeah, hi, Kristen. Thank you for the question. In terms of the two issues that we reviewed today at the Launch Minus One Day Mission Management Team meeting, I would say that we're comfortable flying as is in both of those cases. We did attempt to fully resolve the electrical connector on the tail service mast umbilical, and we're still seeing some funnies on that particular umbilical, but we reviewed the fact that we have redundant data that comes across that interface from the rocket and the spacecraft to the ground side, and as well as the delamination of this RTV material. And then in terms of one moment that would give me the most heartburn between now and launch, yeah, that's a good question. I haven't had time to think about that one. Nothing immediately comes to mind. This is something that it's something we've been preparing for, and we've trained for, and there are a number of decision gates that we have purposely to set up to review our risk posture in the event that something changes, like we saw here as a result of Hurricane Nicole. And I see the team that's prepared to do that. So nothing comes to mind. I don't know, Jeremy, if you have anything to add to that.
Well, kind of given the white dress rehearsals, for me, I'll probably breathe a bit of a sigh of relief after we get into LH2 fast, slow fill to fast fill, right in that time frame. I feel very confident in the procedures that we've worked, but that'll be one of those things where I think it'll be a big milestone once we really get into a steady state fill of LH2, and so that'll be around 4 p.m. or so tomorrow afternoon, and so that'll be something I think we'll all be watching closely.
Thank you. Our next question is from Marcia Dunn of the Associated Press.
Yes, hi. Mike, I'm trying to get a better understanding of the RTV, comfortable flying as it is. Is it that you don't think any more might come off, or if it does come off, that it won't hit the rocket, or if it does hit the rocket, it won't do big damage? I mean, what's your thinking along the lines of risk in that regard? Thanks.
Yeah, Marcia, that's a great question. There is a small likelihood that more RTB that come off the vehicle, but we do have flight rationale that supports that. In order to have an issue in flight, first of all, we need additional RTB to be released, and then it needs to impact part of the vehicle, and that vehicle element has to seek what we call critical damage, and there are limited components that could be exposed to that just due to what we call debris transport and where these objects are relative to where the RTB would be liberated from. So we look at things like, is this within our experience base? Are there self-limiting aspects of this particular material and material release? And we do have self-limiting aspects, like the fact that it is going to tear because it is very pliable, and when it gets into the airstream, it's not going to come off as one really long piece. It will basically break into smaller pieces. And then we do know that this particular material has a very low lift coefficient when you look at it aerodynamically because of how pliable it is. We actually had a witness sample in the meeting today. It was about 12 inches long, and I believe that we've also posted photos online of where we've lost the material for the general public to help understand what the material looks like. And it is very thin. It is relatively lightweight, and it is very pliable. And this low lift coefficient, the fact that we have a physics-based explanation, the fact that it has self-limiting aspects, the fact that we have an experience base of flying with this material, and not just on Orion, but with other programs. RTB is a very commonly used aerospace material, but we also flew ascent and abort test number 2. We flew exploration flight test number 1. We had RTB in a very similar area in both of those test flights, and we did not see material at this same interface liberated during the aerodynamic flight there. So we do acknowledge that there is a non-zero chance that we could have additional liberation of RTB in flight, and that there is a possibility that it could impact a different area of the vehicle downstream of Orion. We know what those areas are. We looked at it all the way down the stack. The most likely area to have the RTB impact the Orion vehicle is on the launch vehicle stage adapter. And the launch vehicle stage adapter is a very tall conical feature that sits between the top of the core stage and the base of the interim crowd propulsion stage. And it literally takes the diameter of the Orion spacecraft and extends it out to the much larger diameter of the core stage. And just the fact that much larger area is there, that becomes the most likely area. The LVSA is a very robust piece of hardware. It weighs about 10,000 pounds, and it is used to translate the 8.8 million pounds of thrust at liftoff of the boosters and the RS-25 engines up into the upper stage, the interim crowd propulsion stage, and the Orion spacecraft that sits above it. So it translates 8.8 million pounds of thrust up into a spacecraft that weighs over 70,000 pounds, and I don't remember the mass of the interim crowd propulsion stage, but we're talking tens of thousands of pounds there as well. So the launch vehicle stage adapter is a relatively inert piece of hardware, and that's the most likely. It's simply a structural adapter, and that's the most likely area that it could be exposed. But there are other areas that we looked at, again, because of the particular material type that we're talking here, and other risks that we have disposition in the past or have in our hazards, like ice and the thermal protection system on the core stage. We considered this to be bounded and within an acceptable range of risk. So that was our flight rationale.
Thank you. Our next question is from Bill Harwood of CBS News.
Yeah, hey, thanks. I'd just like to follow up on Kristen's earlier question to Jeremy. what do you think the odds are with or I don't know, I'm not asking you for odds, but how confident are you that when you get into fueling that you won't have to do manual adjustments like you've had to do in the past, with pressure and flow rates and temperatures management? I mean, how confident are you might be able to just load the fuel and go? Thanks.
Yeah, hey, Bill, I appreciate the question. And, what I would say is we absolutely verified and validated these procedures during what we did was a tanking test following launch attempt number 2. And so what we did there is we spent a lot of time looking at what is the environment around these quick disconnects, what does the seal look like, what are the pressures we're putting on there, and then the associated leak rates. I would say at this point in time, we are more confident than we have ever been in our loading procedures and how to do it in such a way that puts the least amount of pressure on the seals and to really try and keep it quiescent. The other thing is we have a purge can, right, basically around these quick disconnects where, we try and remove, we purge it consistently with helium. And so, and we have hazardous gas measurements kind of coming through there. We've talked with all of our requirements, and we're allowed to have, a momentary transient as we, up pressure because, again, you don't have any, it would just be for a short time period. And that's really the worst case that we saw during this tanking test was you saw kind of a brief spike of hydrogen when you introduced, more than a couple of PSI worth of pressure, and then it quickly came down. And so we've accommodated for all of that in our test procedures and in our safety requirements. So feeling pretty good right now about that kind of going into it.
Thank you. Our next question is from Nell Greenfield Boyce of NPR.
I'm just wondering how you all are feeling. There was a huge amount of attention back in August, and then there were all kinds of things that have happened, the faulty sensor, fuel links, Hurricane Ian, Hurricane Nicole, and, here you guys are again. I'm just wondering, Jeremy, could you tell us, does it feel real now? What's the feeling of the team? Is it like Groundhog Day? This isn't a very elegant question, but I guess you know what I'm asking here.
I know it's a good question. What I'll tell you, if I step back, what I feel is extremely proud of the resilience of this team, and what I would tell you is for all of us, right? It was a bit of a letdown when we had to roll back for Hurricane Ian. What I was so impressed with is the team turned around. We were kind of down that night. Then by the next day, everyone was super focused on what work we needed to do, what we needed to do to get back out at the pad, and then it was a similar story for Hurricane Nicole. By late afternoon, the day after the storm left, we had completed all walkdowns, we had completed imagery. Any issues were largely behind us. I mean, I will tell you the team is firing on all cylinders at this point, and so I just can't be more proud of them because I think if you would have asked me a couple of weeks ago, we would go through a storm like Hurricane Nicole and then be able to turn around and have cleared the vehicle and be in good shape. I would have said, hey, chances are probably low, but this team has really just been firing on all cylinders.
Yeah, and Nell, I would add that the word perseverance comes to mind. The team has had to persevere through numerous trials, and that perseverance in turn has developed character in the team, and that gives me comfort that we're going to be ready when it's our time to fly. As our administrator said, we'll fly when it's right. And Administrator Nelson he stands there with us, understanding that we've got to get this right. And in spite of the challenges that we've had, the hydrogen leaks and the storms and the other technical issues that we've had, the team has done a great job. And as Jeremy indicated, they've persevered through a number of situations, and our time is coming. And we hope that is on Wednesday. But, if Wednesday is not the right day, we will take that next hurdle, that next trial, and we'll persevere through that.
Thank you. Our next question is from Joey Roulette of Reuters.
Hey, thanks. I just had one follow-up on the RTV issue, I guess for Mike Serafin. What other risks does this present that doesn't have to do with the potential for debris hazard? Like, what does this, I guess, mean for the aerodynamics during, ascent? What kind of forces are you guys going to expect to see now that a lot of the RTV is now gone? Thanks.
Yeah, Joey, that is a good question. We did review the aerothermal and aero heating aspects of it, knowing that we had a portion of the RTV on the currently east-facing side of the spacecraft, and because we already have an aerodynamic barrier that sits there, our aerothermal models and the analysis the team has done shows that there's not an issue there. This was just a way to reduce the aerodynamic turbulence and flow in that particular area, but we're within our allowables. In terms of other risks that we talked through, that and debris liberation were the two primary areas that we focused, and really nothing else comes to mind in terms of what we needed to address. It was just the debris liberation flight rationale that we needed a little more time to go resolve. But all the other aspects of the risk were characterized yesterday, and we understand that. So, but I would say that really covered the gamut.